This is Julia,
Lisa,
and Saba.
And this is our Intermediate Statistics and Research Design Paper Critique presentation.
For a copy of the paper, please scroll down to the bottom of this note.
This presentation is divided into two sections. The first is an introduction of the paper, and the second is the critique of the paper.
the paper that we chose to critique was entitled Studying the Effects of Personalized Language and Worked Examples in a Context of Web-Based Intelligent Tutor. This article explored the principles of an e-learning system, which is defined as courses that depend on the web for some combination of delivery, testing, simulation, discussion, or other significant aspect. An example would be our current course, Flex Mode. Context of this study was a web-based intelligent tutoring system, and what makes ITS unique is the context-specific hints and progress feedback, which was shown to lead to significant improvements in learning of high school math and has currently been used in over 2,000 schools across the U.S. The goals of the study were to investigate the effects of informal versus formal language, so first, second person language presented informally. Research evidence has suggested that people put forth a greater effort to understand information when they feel they are in a dialogue. Investigating the effects of worked examples versus practice problems, step-by-step solutions to problems were provided, and they alternated between worked and practice problems. Research evidence suggests that using or solving problems can overload limited working memory, while studying worked examples does not, and in fact can help build new knowledge.
The hypotheses and the research questions are pulled directly from the paper, so given the evidence about personalization and worked examples, our intent in the study described in this paper was to explore the following hypotheses. Number one, the combination of personalized language and worked examples used in conjunction with a supported problem-solving environment, an ITS, can improve learning in an e-learning system. Number two, the use of personalized language in a supported problem-solving environment can improve learning in an e-learning system. And finally, number three, the use of worked examples in a supported problem-solving environment can improve learning in an e-learning system. Based on these hypotheses, then, a 2x2 factorial design was constructed with 4 conditions. Now, if hypothesis 1 were true, we would expect that participants in condition 4 would perform optimally, because this would be an interaction effect between personalized feedback and worked examples. However, if hypothesis 2 were true, we would expect conditions 2 and 4 to be true, because this would be a main effect for personalized feedback. And finally, if hypothesis 3 were true, conditions 3 and 4 would be expected to perform optimally, because this is a main effect for worked examples. So just to show you what the data collection tool looked like, as we mentioned, it's an ITS, or an intelligent tutoring system, and in this case they were looking at stoichiometry, which is a chemistry grade 10, 11 level, and you can actually see an actual question right there. As you can tell, it's a personalized question because it includes first language examples. So did you know that? Can you tell me this? Here's a hint.
In terms of the data collection process, participants first watched a video that introduced the study and explained how to use the intelligent tutoring system. Then they were pre-tested using 9 questions that were presented online using the ITS. No hints or feedback were given, and these questions progressed in difficulty from relatively easy to fairly difficult. Then they were presented to the study problems and placed into one of 4 conditions, and there were 15 questions presented depending on which condition they were in. And following this, they were given the post-test, which involved 9 questions presented online using the ITS. No hints or feedback were given, and again, these questions progressed in difficulty. So this study consisted of a sample of students from the University of British Columbia. They were freshmen and sophomore students, and they were enrolled in either one of 2 courses. The first was an Intro to Chemistry course for chemistry majors. There were 1,720 participants in this course, and the second was an Intro to Chemistry course for non-chemistry majors, and there were 226 students enrolled in this course. The study was an optional online activity in which $20 was given to participants who successfully completed the study. There were 240 participants who began the study, and only 69 completed the study. The authors defined completed as trying at least one step in the final post-test problem. Participants were randomly assigned to one of the 4 conditions.
Different scores were calculated for each participant, which were calculated from post-test minus their pre-test scores. 6 subjects in total were removed, and the condition 1 had 16 participants, condition 2 had 16 participants, condition 3 had 19 participants, and condition 4 had 12 participants. So to test their hypothesis, they first did a 2x2 ANOVA with 2 factors and 2 levels. The 2 factors were personalization and worked examples. The 2 levels of personalization included personal versus impersonal language, and the 2 levels of worked examples included worked versus problem solving. So to test overall differences between pre- and post-test scores across all conditions, they used a 2x2x2 repeated measures ANOVA. Within subjects variable was time, so pre-test and post-test. Results are presented in the following two tables, so the 2x2 and the 2x2x2 ANOVAs. To summarize, there was no interaction effect between personalized language and worked examples. There was no main effect of personalized language, and there was no main effect of worked examples. The effect of time, however, did reach significance at the 0.00 level. Researchers then further divided subjects into three groups, so novice, proficient, and expert, based on the results of pretest scores. Post hoc analysis revealed that the novice group had the largest mean score gain from pre to post test.
So in conclusion, as Lisa summarized, none of the three hypotheses were supported. So a combination of personalized language and worked examples used in conjunction with ITS do not significantly improve learning. Personalized language used in conjunction with ITS does not significantly improve learning, neither does worked examples used in conjunction with ITS. However, what the researchers did conclude is that web-based tutoring can be effective as indicated by significant learning gains for all conditions. Moving on to the second part of our presentation, we're going to talk about our paper critique, which is divided into 5 sections: study design, data collection, data analysis, results and interpretations, and finally future directions.
In terms of the study design, there were inconsistent definitions of the use of personalized language. They referred to it as conversational versus dialogue and so forth. Also, the informal first and second person language alone does not necessarily create a sense of dialogue. Prior research on the role of politeness in the conversational style of an on-screen tutor suggested that it wasn't just the conversational language that made a difference, but the development of a real social relationship and engagement with the learner. Also, it's the unclear format of worked examples were narrated by chemistry experts could possibly confound with the language styles investigated. We couldn't determine with certainty whether or not the chemistry expert film excerpts involved personalized language or otherwise. In terms of the study design, there were problems again with how they defined worked examples, and also with what they chose as worked examples. These examples may have been inappropriate for some of the study sample recruited, because previous research findings have shown that expert students benefit more from problem-solving questions versus worked examples. Also, these examples could have been ineffective altogether, because whereas only 48% of participants actually finished the first worked example, as few as 26% actually made it to the last worked example. So there's obviously something going on there, whether or not they're ineffective. Previous research has showed that alternation between worked examples and practice problems may have actually confounded the effects of the worked examples.
So in terms of the data collection tool, as you might have noticed in our examples that we showed earlier, the questions are heavily language-based, and according to the researchers themselves, they did not collect demographic information, but the UBC chemistry professor said perhaps more than 50% of the students were non-native English speakers, so the effects on ESL students is unclear. Also, there was an extensive number of steps required to correctly solve a problem. So for each question, each participant had to express the goal, fill in all of the terms, so all the blanks in the equation, convert the given value to goal value, and provide rationale for each term. For example, the total possible correct steps for the pre-test were 231, and for the post-test, 222. In terms of the data collection process, there was no indication of timeline, even though time was used as in making the main conclusion of the paper. So, for example, it's unclear whether the participants were required to complete all 33 questions in one sitting, because if that was the case, you would get fatigue effects and possibly testing or carryover effects. And finally, the data collection sample. As the researchers themselves mentioned, stoichiometry is appropriate for grade 10 or 11 students. However, this was tested on undergraduate students. And as the researchers identified, the fact that our subjects were not novices may have made it difficult to get an effect. Also significant, there was no comparable control group. The sample composition was unclear, so they mentioned how both freshmen and sophomores, as well as chemistry majors and non-majors, were included in the sample, but it was unclear how they were distributed within the various conditions. There's a failure to collect demographic data, as mentioned earlier, so things like language, prior experiences, age, and sex. And finally, there was a high experimental mortality, so basically the dropout rate was quite high. 29% of those who began the study actually completed it, and that represented 3.5% of the entire population of interest.
In terms of a critique of the data analyses, it's unclear why scores for the pre and post tests were calculated to fall between 0 and 1. This was the number of correct steps divided by the total number of possibly correct steps, but it's unclear as to why they made that decision. Also, the assumptions for the 2x2 ANOVA, most were achieved, but one was violated, and that was the dependent variable normally distributed for each of the populations as defined by different levels of the factor. The post-test scores were slightly skewed, so that was one assumption that was violated. The rest were achieved. Also, the 2x2x2 repeated measures ANOVA with time seemed to be used in place of a matched control sample. While conclusions support the analyses and the results, there were significant sampling issues such as an unrepresentative sample, lack of sufficient power size due to small sample, and a lack of match control that ultimately render these analyses uninterpretable in a meaningful context.
The major strength of this study was the support for web-based learning programs. There is a second study currently in the works. Their sample consists of high school students, mostly native English speakers, and they're using worked examples that are modified, so participants must fully watch videos and correctly answer a few self-explanation questions before being able to proceed.
And that concludes our presentation. Thank you for listening.